Hey guys, just wanted to present the answer to the probability distribution problem from yesterday's video. Remember, this is the spinner with 5 regions on it. The $100 win, the $50 win, the $20 loss, the $5 win, and the $5 loss. So we have to establish the random variable first, which is the actual outcomes of this situation. The actual outcomes is what happens in each region of the spinner, or the circle. So the random variables in this case are the $100 win. These are your x values. That's what the random variable is. The $50 win, the $20 loss, the $5 win, and the $5 loss. Remember, the random variable, the selection of random variables should always include every possible outcome, which is why the probability values, when we do the second column, always add to 1, because all of your outcomes are there. Now, as far as the probability, we have to determine what's the probability the spinner will land in each region. And I told you in the video that the top 3 segments are split equally into 1/3 of half the circle. That makes each one 60 degrees. So you can think of it as 60 degrees is 1/6 of 360 degrees, the whole circle. And 60 360ths is 1/6. Or you can think of it as 1/3 of 1/2, which is also 1/6. Any way you slice it, the probability of landing and winning $100 is 1/6. Same for winning 50, and same for losing 20. The 5 and the -5 are both 1/4 of the circle, so the probability of winning 5 is 1/4, and losing 5 is 1/4, and those two are just going to cancel. So when we sum our 5 probabilities, we get essentially the expected value. Oh, sorry, we don't not get the expected value. We get 1. We better get 1, or we don't have a probability distribution. And 1/6, 1/6, and 1/6 is 3/6, or 1/2, and 1/4, and 1/4 is also 1/2, and 1/2, and 1/2 is 1. We get our expected value from multiplying the random variable by the probability associated with each one. That's x times p of x. And I'm just going to do that now. 100 times 1/6 is 100/6. 56, -26, 5/4, and 5/4, -5/4. And again, those are going to cancel each other out. So we're really just adding the top 3, which is 156 minus 26, or 136. And this represents our mu, or our expected value, the mean of this probability distribution, what we would expect to get as a return if this was repeated many, many, many times. And what is 130 divided by 6? About 21.7. Remember the round-off rule for mean and standard deviation: one place after the decimal more than the random variable. Random variable is integers in this case. So 21.7. Okay, we also need the standard deviation. How much spread would we expect with this situation? Formula for that is the square root of the sum of x squared times p of x minus the mean squared. So I made another column for x squared times p of x. Remember, x squared comes first, so the random variable squared is always going to be a positive number. And probability will also always be a positive number, so it's going to be a positive times a positive. We won't have any negatives in this column. 100 squared is 10,000 times 1/6 is 10,006. 50 squared is 2,500 times 1/6, 2,506. -20 squared is 400 times 1/6. 25 times 1/4, and 25 -5 squared is also 25 times 1/4. All right, a little fraction lesson here. We're going to add these up. You could convert them to decimals if you like. That's fine, but there will be rounding error if you do that. I'm going to go ahead and keep them as fractions. I'm just going to convert each one to a common denominator of 12. 6 and 4, both smallest factor of 6 and 4 is 12. Let's go 12ths, 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 and 12ths. Anything with a 6 in the denominator that we're converting to a 12 in the denominator means we're doubling the denominator, so double the numerator. 20,000 twelfths, 5,000 twelfths, 800 twelfths. 4 goes into 12 3 times, so we triple the numerator for fourths, 75 and 75. Add those up, we got 25,800 plus 150, 2950. 25,950. That's what we got. 25,000. Oh my goodness. Wrong button. 25,950 twelfths. And that is x squared times p of x summed, or all of this over here in the formula. So all we have to do is square mu, subtract it from the result of 25,950 divided by 12, and then take the square root. So carrying on, got a different color, but oh well. 25,950 divided by 12. 20. Did I do this wrong? 25,950. Yeah, 25,950. Yeah, I did it wrong before. 25,950 divided by 12 is 2162.5. And 21.7 squared is 470.9. Subtract 2162.5. And that is the square root of 1691.7, which is about 41.1. And that is your standard deviation and your expected value. Okay, guys, hope that helps in the future. We'll keep doing more of these probability distributions. Bye.